Welcome to Ecosystems Over Time. So, for this lesson, we are going to be looking at a key term called succession. We're going to look at the two types of succession that are involved in ecosystems. And really, for you to be successful in your understanding for this lesson, is you're going to have to be able to describe an example of succession, what occurs in these two types of succession, and how you can distinguish the differences between them. And then we'll finally finish this lesson by looking at um, some of the reasons that we can understand how succession has occurred and how it's occurred over millions or billions of years, and how we can find evidence of what environments or ecosystems, what they used to look like based on this. Today's lesson is proudly sponsored by Millie. She may pop her head in every now and then. See how we go. All right, so first thing that you need to understand is that an ecosystem responds to the abiotic changes that occur over time, and that'll influence basically the biotic components of an ecosystem, and the opposite occurs as well. And so, what I mean by that is when we get changes in the abiotic factors, so things like air temperature changes or water changes due to drought or high rainfall, or nutrient mineral changes due to the movement of soils or anything like that, that will influence how the biotic factors will interact with that ecosystem as well. And so, for example, if we look at air temperature, in the cooler months of certain environments, you might get a lot of snow, you might get a lot more rainfall and things like that. You won't get a lot of plant growth. And so, organisms or primary consumers that consume the producers, they might actually then migrate, hibernate, or die off. See, she's back again, round two. Go away. Um, Same goes for when an environment experiences either large amounts of rainfall or water shortage as well. So that'll influence basically what can live there and at what time. And we see this happen seasonally, but we can also see this happen daily, in terms of the behaviours that organisms might exhibit throughout the day. Um, and we can see this over longer terms. And that's where the key understanding of this idea of succession comes along. So, succession, when we look at it, is the significant change to an ecosystem where both the abiotic and the biotic factors are completely changed for the environment and it doesn't go back to what it originally was. So, this happens in two different ways. So, the first way that we're going to look at is a process called primary succession. It takes a very long period of time, where the second one is secondary succession, and this occurs at a much faster rate due to an event such as in the picture that you see there where you have a bushfire. One thing to know about this process of succession is it travels in one direction. So the environment is permanently changed and it doesn't go back to its original state of what it once was. It might be similar, but not actually what it once was, because you'll get a whole different variety of producers, consumers, and decomposers that potentially could come into that ecosystem. And so the first concept we're looking at is primary succession. And so this is where we consider a barren environment, so an environment that is made up of lifeless sort of abiotic materials like big rocks, gravel, and non-nutrient rich soils. And so you can see in the first picture there, bare rocks, gravel, and bare sand, gravel, and rocks left after the retreat of a glacier. So we've got an environment that does not sustain life very well. However, what we do get is over quite a long period of time is we get processes like weathering and erosion that occur, which allow for some small cracks, which allow for some breakdown of those rocks and maybe the gradual release of some of those minerals within the rocks. And then we can also get, basically, you can get things like spores or small seeds that are blown over into the environment. And we get these early types of settling organisms, these early producers that are really opportunistic, that can thrive in harsh conditions, that are able to start to establish themselves there. Like all living things, mosses and lichen will grow, but also die. And so when they die, they'll recycle nutrients back into the barren soil. But essentially, what that does is it starts to create more nutrient rich soil. Eventually, over a very long period of time, you can start to then have conditions that become more ideal for sustaining a richer diversity of life. And so you might start to get the seedlings or the germination, which is basically the movement of seeds through wind or other kinds of processes into that area. And they can actually establish small grasses. There's no competition, the soil's barely rich enough, but it's able to sustain some early forms of life. So we'll get the establishment of now start of those sort of photosynthetic organisms, those early producers like grasses and small plants, which will in turn attract things that eat them. And so you can see in that third picture, we're now starting to see there might be some different organisms that can exist there that might eat those grasses and things like that. So we're starting to establish an ecosystem. And then once the conditions are sort of we're getting enough nutrient and energy flow throughout that ecosystem, we can start to get more shrubs and trees and mature soils in that ecosystem and start to attract a more rich range of organisms as well that are going to consume that. And in turn, we can start to get then more mature types of organisms as well and bigger organisms. Thanks, Millie. And so we can see this happens over quite a long period of time. And we'll see sort of how long that is in a couple of slides, I believe. So, what I do recommend here is that you pause, have a read through. Really, this just talks about what I've spoken about, but it gives a lot of those technical terms that I might have missed over in my conversation. So, when it talks about things like autotrophs, that's talking about photosynthetic organisms like grasses, things that conduct photosynthesis, or mosses, things that actually can create organic material from inorganic matter. Um, and yeah, it talks about the different processes that occur. And again, just after you've had a read of that slide, relook at this picture and sort of just get a gauge for how that ecosystem or environment might change over those 4 different snapshots. Now, what you might have noticed on that last slide is that that process says several hundred years, and that's really what we're looking at. We're looking at a long-term kind of change to that environment. When we look at this concept of secondary succession, we're looking now at a change to an ecosystem. So it's the same, it's a massive change to an ecosystem, but we're looking at it from a different lens. We're looking at it because a event has occurred. So that ecosystem has been disrupted permanently due to a massive event. So that event can be from things like a fire, it could be from a cyclone, it could be from um, deforestation or anything like that. The difference between the primary succession and the secondary succession is the soil quality is still as it was before the event. So when a fire occurs, we might lose a lot of our big mature plants in the area, or we might have a lot of damage to them. However, the nutrients within the soil still remain, which when we look at primary succession, if I go back a slide, in those first 2 slides, the first 2 pictures, the nutrients are just not there in the soil. So that's why you can't sustain deep-rooted trees and large plants and things like that. Secondary succession happens at a much faster rate because we've already got those sort of key components for life already there. We've already got nutrient-rich soils. We've probably already got good weather conditions for growing. It's probably likely that environment's going to experience rain again in the next season. So we've already got sort of some of those key components for establishing the early parts of life. Now, the key difference, and this is a really good graphic to demonstrate that, is you can see in both of those pictures the depth of the darker soil. And so you can see in the secondary succession, the depth of that nutrient-rich dark soil is maintained the whole time period. Whereas in that first picture there, the depth of the nutrient-rich soil is only gradually developing over time. And so the length of time when you're getting things like your pioneer species occurs much quicker in secondary succession, whereas your pioneer species, so your things that can tolerate harsher conditions, such as your mosses and your small plants that don't need as much nutrients, they take a lot longer to grow and be maintained through an environment so that they can basically lead to the secondary or intermediate species like the smaller plants or the smaller trees to actually establish themselves. All right. The last thing I'll say on this is that when you're thinking about a question that's associated with this, you have to think about, was there a key event that occurred? If so, how long is it going to take for the re-establishment of that ecosystem? Primary succession is thousands of years, if not millions of years. When secondary succession, we're talking this could be 10, 15, 20, 100 years, and we've already then got a well-established and rich ecosystem. If we think very long-term change, we can look at fossil evidence from what we can see imprinted in certain areas across Australia and across the world. We can see that while we have quite a dry, hot, and sometimes in some parts of Australia, humid environments, and in other parts of Australia, quite very sparse populations of shrubs and other organisms, we actually find in our fossil records that there were different types of organisms that actually survived in much different climates and different environments. And that, when we're looking at millions of years into the past, we can make assumptions based on weather patterns and things like that based on the geological records that exist there. So if we know how organisms grow, survive, and what their needs are, and we can see fossil records of certain types of organisms or evolutionary lines of those organisms because of similar genetics or things like that, whatever it is that we look at in our geological profiles or our biological profiles, we can make judgments on what the environments might have looked like back then. Take, for example, in the Flinders Ranges, like I said before, is now very hot, very dry, very arid. However, was actually the bottom of a shallow sea. And so we would have had a completely different environment. We would have had completely different weather patterns and things like that. And then we would have had big events or long-term events like volcanic eruptions, movements of continental plates due to drifting and other kinds of processes as well. And then probably nothing for a very long period of time. And so maybe some evaporation of those waters, and then not the recharging of those waters over a very long period of time. And so that's how that environment can change over millions of years. I do recommend watching those videos, by the way. And also have a quick read of this as well, talking about dinosaurs within Australia as well and some of the fossil records that we see of them. And also some of the fossil records that we can see of megafauna as well. So massively large marsupials, which are actually really cool. And if you think about it, the reason that we can't sustain these kinds of organisms now, these things that are 2.5 meters high or anything like that, is just because we don't have the kind of ecosystems that would support them. So there's not enough energy or matter that flow within that ecosystem because of what the needs are of those kinds of organisms. So they might have gone extinct or from a big event, or they might have gone extinct over a longer period of time just due to a changing environment that they weren't able to survive and thrive in. And so that's why you see nowadays a lot of our marsupials are much smaller because the needs of that organism are much smaller so they can survive in environments that offer much less. And we'll finish up by you being able to, if you do want to have a look, this sort of goes into some of the extinct and enormous megafauna that we used to see in Australia. And a lot of the processes that you'll learn about in year 12, biology, as well as to how we get divergence of those species into similar ones that we might see today. All right, thank you.